partner at Archetype. We have a great crew here. Let's start with 30-second intros to my right, what you're working on, who you are.
All right, rapid fire. Hello, everybody. Austin King, co-founder of Omni Network. Omni is basically an interoperability solution purpose-built for the Ethereum ecosystem. We use restaking to pull this crypto economic security budget out of Ethereum itself and use it to let rollups talk to each other. I know it's been a long conference. I'm going to intentionally make this a little more spicy, so looking forward to this.
Hi, I'm Susannah. I'm the product lead for the IBC team at the Interchain Foundation. IBC stands for Inter-Blockchain Communication Protocol. It's a generic interoperability protocol that can connect any blockchains, but it's used predominantly in Cosmos right now. So yeah, looking forward to the panel.
Hey guys, my name's Fig. I'm one of the co-founders of Squid. And Squid is a API and set of developer tools that let you take any token on one chain to any token on another in one transaction and do other more complicated things like buying NFTs in one click on any chain, staking on any chain. We're using IBC under the hood as well as Axelar, which is an underlying interoperability network.
Hey guys, I'm Brandon from Zetachain, and we're working on a Omni-chain blockchain. So what that means is we connect natively to pretty much any blockchain agnostically and serve a EVM programmable layer where you can orchestrate, transfer, do anything you want with those assets. So the most exciting piece is Bitcoin right now. So trying to enable new use cases for using Bitcoin with the rest of DeFi and crypto.
Cool. So I'll try to make it a little spicier, I suppose. I think with Ethereum, as you compare it to Cosmos, one of the issues is that with the rollup-centric roadmap, I think Interop is a second-class citizen. So with Cosmos, that's been outlined from the start, and I think now we're kind of backing into solutions, and I think there's pros and cons, but high level, what do y'all make of that?
Yeah, I agree. I actually totally agree. So this is why we're building Omni. There is no canonical path towards having Interop in the Ethereum ecosystem. And so what we're seeing is the global network effects of Ethereum are just obviously degrading. And so this is a clear problem, especially as platforms like Solana just offer a way better user experience at this point. And so what we're particularly focused on is just uniting all these different rollups that have created this fragmented ecosystem. And particularly, we're focused on doing that in a way where we're promoting open standards. So, I don't know if people here have heard of Axelar ITSs, Layer 0 OFTs, more of these proprietary token standards. Fundamentally, we think that's a bad idea. There's been a ton of hacks in the space. A lot of that money went to North Korea, pulls a ton of bad attention into it. And so instead, what we can do is design open standards like XERC20, which is a token standard that gives asset issuers themselves sovereignty over where the asset goes. They can whitelist interop networks, they can blacklist them, get them off, they can put rate limits on it. It's fundamentally a better design, and we've been driving a ton of traction around this recently. There's over $7 billion cumulative market cap that's committed to using these standards. And honestly, selling it to these teams is not that hard because it's just a better product than what's out there in the market. So the way we see this going forward is there's the interop space here where it's how do people use these tools? That should be open standards. And then there's the verification layer of how do these messages get passed around. That's really where I think most of us, not IBC, are involved in the space though. So that's how we see it. It has not been formally first front and center in the Ethereum roadmap, but that actually presents a lot of opportunities to teams out there.
Yeah, I think Ethereum was clearly a pioneering blockchain and design philosophy of its time. And when it launched, it actually had lots of core principles around interoperability. But that notion of interoperability was between applications built on Ethereum. And then I think Ethereum just grew so quickly and gained so much traction and delivered so much value to the blockchain space that it actually kind of outgrew itself. And rollups, I believe, it wasn't the first choice for the scaling solution, but it enabled more people to get involved in a more active way. But all of these people building their own rollup frameworks, bespoke rollup ecosystems, they're fundamentally not incentivized to cooperate. And this is kind of a consequence as well of Ethereum not being definitively opinionated about interoperability and leaving it up to kind of app layer primitives to decide how that should be. And that's in contrast to Cosmos, where you say interoperability should actually be a core kind of fundamental primitive of blockchains, and applications can be built with that primitive rather than like leaving it up to applications to solve that.
Well, that's an issue as well, right? Because I think what we're seeing is you have, the OP superchain that's doing their own like flavor of interop. You have ZK Sync, hyperchains, Starkware, fractal scaling, Arbitrum, Orbit, doing, so I think that's also a fundamental tension where you seem to have these L2 ecosystems trying to bake in their own like native interop. At the same time, you're trying to solve for how do you do cross L2 and cross L3 interop.
Yeah, it's like the XKCD meme. Like, everybody's got their own solution. Yeah.
Yeah, I agree with everything these guys have said. I think the lack of standardization can be seen as a feature, though, not a bug. Part of the beauty of Web3 is that you don't get the protocol given to you. You can innovate at the protocol layer. And despite the connections between all these rollups, it's actually the innovation that every new rollup brings. They're like doing a new type of ZK or a different gas model or how they incentivize builders. And from my perspective, our API aggregates a bunch of different chains, and we use Cosmos and Ethereum. And the hardest part isn't actually aggregating the interop, it's aggregating all the different micro changes that each one of these L1s and L2s has put into their stack. So I think the things like standardizing the interop layer is actually not the biggest issue. Like we're dealing with getting just transactions included in a blockchain can be really hard when you are used to doing it on Ethereum. And so, yeah, I think we should move towards this idea of creativity and keeping protocol innovation like possible, rather than locking into standards. You can think of like email. It's been outdated by messenger apps like WhatsApp and Facebook Messenger, for example. Like, it's much easier to communicate these ways. We use Telegram for communication in our own business, and the protocolization of email did a great thing for making the internet connect with itself, but it also meant that we had to do this leapfrog into a new technology. So yeah, I think we should keep this fluid motion until we find something where everything's working, and then maybe we settle on a standard.
Yeah, I have to echo what you said. I think there is still kind of like, we're still in the state of dust settling of L2 strategies coming up, interop solutions coming up. So I don't really follow exactly how the EF works, but my guess is there's not really a clear winner in what interop should look like, and if that should maybe expand beyond the Ethereum ecosystem in some way, kind of like IBC. The way we look at it is kind of flat, so other L1s or L2s in the EVM ecosystem are kind of ripe for making interoperable. So rather than kind of just sticking to the EVM ecosystem, can we have something that is standardized across all, like expanding XERC20 or whatever those standards are to general fungibility across Cosmos chains or Bitcoin or what have you?
Yep. And I guess from a project perspective, when I think about, the design trade-offs that an L2 takes and just the nature of it being an L2, how do you think about how that informs your own designs? Are there any key kind of like differences that you are afforded when you're working with L2s, and how that informs your specific projects from either a cost, extensibility, security perspective? Like what's the main difference you think between facilitating interop between L2s and L3s rather than the different L1s, I suppose?
Yeah, so I think one of the most interesting things here is the amount of innovation that we can have at the L2 layer itself. Everybody's just building EVM equivalent rollups today. Like, cool, glad we have rollups, but there's a ton of room for innovation on the actual like VM that is running there. That's going to enable us to bring far more developers into the industry at large, because people don't know Solidity. And frankly, Solidity is not that great of a language to work with. So if we can design VMs where people can program in Rust, that's fantastic. Other languages as well. So Omni specifically, we only work in the Ethereum ecosystem. We built this network very intentionally to be the best product for the biggest market. we don't work with other blockchains. Historically, all interop protocols have focused on bringing assets and like data to other blockchains. We don't do that. It's purpose-built for Ethereum. It pulls security from Ethereum itself. And intentionally, when we started designing this network, we did it in a way where there was a very minimal requirement for integration. Rollups don't actually have to do anything to get integrated into the Omni network. The Omni network sits above and actually observes these state updates itself. So one thing that we saw when we started designing this about like a year and a half ago was that there would be a proliferation of VMs here, and we needed to empower further innovation to happen at the L2 layer. We don't care if it doesn't make a difference to the Omni network if there's different VMs there, and that's the way this stuff should be designed. If you look at the internet protocol stack, there are like very minimal requirements when you move from like one layer of it to another. I think in this space we have had just like a very silly perspective, and like sometimes teams market themselves as like the TCP IP of crypto. That's nonsensical. Like TCP IP does not have a business model. All these networks, they might not be companies, but it costs money to secure them. They have a business model. They have to take revenue somewhere. The reason the world uses TCP IP is because it does not privilege any specific entity that's out there. It's just a minimal standard. And so that's how we looked at it. It's just like, what is the minimal amount of work, or like the minimal data structure and like compliance that we need with these rollups? Our perspective on it is like, the world is going to be built on Ethereum. Like, right now, the user experience is terrible and it's super expensive, but by the end of the cycle, it's going to look like Solana. Like, we are building these externalized networks that still have the security of Ethereum itself, and by the end of the cycle, like, we are going to have like sub-second finality from the user experience perspective. So that's how we look at like how you should look at all these like different architectures that are out there. Require the least amount possible from them so you can cover everything globally.
I think maybe I just want to know, like IBC is a little bit different in that the protocol fundamentally doesn't extract any fees from people that use it. So
to be clear, IBC is the closest thing to TCP IP we have, because it's not a network, it's actually a standard.
Okay.
Yeah.
Well, okay, then I guess, yeah, that was basically my point, just to note that it is maybe slightly different from what we think of bridges or things like that today. But yeah.
Makes sense. So I want to talk about a couple of different flavors of interop that I think is emerging given L2s. One way to do it is through shared sequencing. So instead of having an externally verified bridge, you have a sequencer that does the transaction ordering for multiple rollups. And so in a way that gives you some flavor of at least inclusion guarantees, maybe not execution guarantees. Some projects have claimed you can do it. Why do we need external bridges at all if we could just have interop via a shared sequencer network on an L2?
Yeah, I think a shared sequencer interop is something that's really exciting, but we want to see in production and see someone actually build with it, and then what the developer experience looks like for sending a message between two, say, rollouts which share a sequencer. And my view is that we've already seen multiple different sequencer projects pop up, so there's going to need to be interop between those, let alone we still have Solana as a, there's going to need to be interop with Solana and all these new tech stacks which get built. So I think interop still has a future. But my view is definitely that we should still use the most secure stack, like say the L2 or L3 native bridge, for collateralization of assets wherever that's possible. But because often they're quite slow, like optimistic bridges take 7 days, we still need an extra layer for making settlement and execution happen between these environments quickly. And then you maybe have an even third layer on top, which is with intents, which gives you instant finality, but much worse liveness guarantees, for example. So I think we'll always have a blend of all of these different architectures to give the user the best experience with the highest security. Yeah.
I think with shared sequencers, as you already said, it's like if you use a shared sequencer network and you have multiple rollups plugging into that, you can guarantee inclusion. But if you actually want to start guaranteeing execution, you need to add additional proofs to that. And then you're already starting to building something that's increasingly looking like the inter-blockchain communication protocol. So to me, it's like with all of these design spaces, if we want to have something which is, has trust minimization, those kind of core principles that we want for interoperability, they're all going to kind of converge in this design space of some kind of like client proof-based interoperability. And I think the shared sequencer interoperability is going to be no different, especially for people that are looking for atomic execution as well.
I think one thing to think about here as well is shared sequencers are awesome. This is going to be super cool. You know, for a long time, I think a lot of people viewed decentralization of the sequencer as like a regulatory arbitrage opportunity. Obviously, there's risk with just running a CPU that processes all these transactions. So what we're seeing now is you can get pre-confirmations out of shared sequencers. And so this is going to be a fundamental thing for the Ethereum ecosystem. Like the leading shared sequencer team, in my opinion, is Espresso, for example. What we're going to be able to do in collaborating with Espresso is their shared sequencer networks are going to be able to issue pre-confirmation of inclusion of transactions. They'll have to work with builders in this, but still, you can get this down to like 100 millisecond level, and this is how we're going to achieve the Solana UX on Ethereum itself. And what we can do is we can relay those pre-confirmed transactions across different rollup environments, whether that's to a single rollup or to another shared sequencer environment. But like at large, there's still going to be many different shared sequencers, fundamentally because we need more throughput on the network. None of these distributed consensus protocols can handle like the real vision of Ethereum of processing, you know, like hundreds of thousands, millions of transactions per second. So fundamentally, there's still like a throughput constraint, and that's what's blocking the vision of just like all rollups becoming a big shared sequencer.
Yeah, for us, like I was saying before, we're heavily focused on L1 connection, and our hesitation to connecting to certain L2s is we don't have things like shared sequencers that make it kind of like a more sustainable thing to connect to, because for us, if a chain in our sort of hub and spoke model is compromised or whatever, that can have ripple effects to other assets on other chains that we're connecting to. So yeah, we're bullish on whether it's something more like IBC or L2 shared sequencers to come to the game to where we can start integrating L2, so we can do L2 to L1, L2 to L2, L3 to LX, what have you.
Yeah. But there is this fundamental tension between security and cost slash speed slash extensibility, where I believe probably the most secure model is a two-way light client bridge, where you're actually doing a consensus proof. And I think the benefit of being an L2 is you do have cheaper execution fees. So you can either verify a validity proof of the light client, or you can actually just do the light client verification directly on the L2. You can potentially have a light client bridge from an L1 to an L2, and that feels cheaper. So the ideal state in my mind is, why don't we just have bidirectional light client bridges, ZK verified or not, and then just have that be the most secure model?
Yeah, I think we're gonna make it spicy. I think that's a nice picture of the world, but it's very impractical. Like, I don't know how like versed the crowd is in ZK, but generating proofs for moving, well, one, you need finality on these things, so that's a huge problem in the Ethereum ecosystem. But the cost to generate ZK proofs at this time and the time to generate ZK proofs at this time make them a terrible solution for interoperability today. In like 4 years, are these probably going to be an incredible solution for this? Yeah, like next cycle where we're kicking things off, I imagine this will play a very important role in interoperability. But I actually disagree with the fundamental premise here that like there's a trade-off between all these things. And I think that's solved with restaking. If you have a network that is crypto-economically secured, that gives you extreme speed. Like our network reaches consensus in under a second. And so we have an extreme level of security. Literally, like this will be billions of dollars, something that has never been able to have been achieved before with an external network that did not pull a security budget out of Ethereum itself. But I think that like used to be the state of the world, but it's just not the case anymore. Like using restaking, you get the best of security and performance. Down the road, we'll play with ZK more. It's impractical today, though, for Interop at least.
Yeah, I mean, I do think the future will converge on ZK-based solutions. And I mean, it's clear on the Ethereum roadmap, right? They have single slot finality coming up. They have a lot of stuff around snarks and snark-based proofs, having a proper light client that's not just based on the sync committee. Like, it's clearly coming. But yeah, I agree. It's about the timeliness of it. So yeah, there is always a trade-off until we reach that kind of, the technology is ready.
Yeah. Cool. Well, we're at time, and unfortunately, maybe one last question from my right, I suppose. How many L2s do you think there are going to be in 5 years?
Millions.
Millions. Nice.
All right, everyone. So now is the perfect time for a break. So if you need to grab a coffee, take some sun, or call your mom.